Hello, good evening. Hello, good evening. Thank you for being here. Thank you for being interested in our topic to learn and discuss about prototyping. How can you prototype hypotheses and also potential solutions in a space that is complex? It's a complex environment. There's a high cognitive load for drivers and passengers. And you find yourself also in a fast-moving object. So we're going to learn about that in a second. Welcome, everybody, to our Munich Creative Business Week event. There's around 140 people who have signed up for this event. Those who are present here physically, but also there have many people signed up to be present digitally. And welcome also for me personally. My name is Manuel. My title here at Star is Head of Design. I work for our teams in Copenhagen, in Wrocław, in Milano, in Frankfurt, and also here for the team in Munich. And I need a sip of water. Oh. You can find those folks who are based here in the office by identifying them via the name tags. If you have any questions, if you want to chat them up, please do so after the event and also, during the event and after the talk. Yeah. Quickly about the logistics, I guess by now you've found the snacks and also the drinks. The restrooms are right over there behind this wall, and yeah, if you haven't seen the roof terrace, please check it out later. The talk that we have prepared is gonna last around 30 minutes, including a Q&A, and also there's a bit of time obviously afterwards to discuss and talk. The event is scheduled to last until 10 o'clock, but let's see how long the drinks last. Yeah. And with that, I would say let's get going. Quickly about Star. We are a global company. We have 14 locations. The latest one in Colombia, in Medellin. We have around 750 engineers and 100 designers in the company. And so it's a ratio of 1 to 7.5 approximately. And we work in many different industries. Automotive is definitely one of them, and it's also very, very strong here with our design team in Munich. But we're also active in other areas: fintech, health tech, edtech, and marketing technology and advertising technology. So this shouldn't be a corporate presentation, so we kept the intro of the company very short for you today. You can ask questions. You can definitely ask questions for those of you who are here physically after the talk. There's also a Menti space where you can ask questions, and that might be even more relevant for the folks who are joining us online. And with that, I would hand over to the two folks who are gonna walk us through the talk today, Thomas and Dominik. Yeah.
Thanks,
Thank you.
Great. Awesome. Wow, it's great. It's great seeing you all, guys. So hi, my name is Thomas Helmer. I'm principal designer here at Star. I joined Star roughly 4 years ago with a background of industrial design. And at Star, I work at the intersection between industrial design and user experience design, namely storytelling, service design, and things like these. And many times I work in the automotive sector. So I'm very happy that we have the speech today.
Hello, also from my side. My name is Dominik Fink. I work at Star for 3 years now. I work as a UX designer, mainly focusing on prototyping, making concepts tangible, where we would also like to talk about today. And yeah, my main focus is also in the automotive industry. So I've been working on a lot of automotive projects in the past. But now let's dive deeper into today's topic. Imagine you are sitting in a car, driving with your navigation app, and you want to change you want to check for alternative routes. We all know that situation, but what if there would be a better way to interact with the car? So for instance, we could imagine talking to the car, we could use voice commands to get an alternative route, or we could also have a companion AI which would make the experience way more better. So we as designers are often creating these concepts, and we always question ourselves how to make them tangible and how to make them achievable for the customers. So this is where we believe that prototyping and testing comes in and is a key enabler for being innovative. So today we are going to talk about how we create these concepts and how we in our team are using prototyping and testing for building innovative concepts in the automotive industry, for putting these ideas to the test and also making them tangible. So let's dive deeper into the world of automotive prototyping and research. So first of all, let's take a look at the why. So why is testing and prototyping important in the automotive industry? So it is really valuable to bring ideas to life and make them tangible. So to make them tangible for a specific audience, user group, or individuals. In addition, it is an effective tool to communicate and pitch a vision and to get a common understanding of a concept. At STAR, we believe that prototyping and testing is a key enabler for innovation. It supports us to drive innovative concepts and help our clients being competitive and sustain in the market. On top of that, prototyping and testing can help automotive companies understand customer preferences and expectations, as well as also discovering problems and limitations early on to make the necessary adjustments before moving forward with mass production. And another one, it is very important, it is a very important step in the product development process in general. We will also talk about this later, for gathering feedback, for defining new functionalities, and also for validating design concepts early on, as we said. So in short, prototyping and testing is an essential tool for the automotive industry to remain agile and also responsive to disruption and drive innovation. So,
yeah. So businesses must make daily decisions about navigating into the future. Because of changing market condition and changing customer needs, businesses need to adapt basically on a daily basis and evolve to stay competitive, innovative, and responsive to the market. So we get these questions a lot here at STAR. How might we improve their product experience? So how can the client stay relevant despite the external change? How might we create more value for their customers? So how can we strengthen their portfolio and brand image? And last but not least, how might we make the best use of the latest technologies? So what does the future of the industry look like if we can implement these technologies? And all of these questions demand for a customer-centric approach to deliver value and address the customer's needs. However, many choices are made in an environment of uncertainty. So how can we effectively take decisions? And what would we base it on? So we think that the best foundation for this is research. And in particular, we want to highlight the importance of testing and prototyping in this presentation. Okay, so prototyping and testing, it can help us identify potential issues and areas for improvements early. It informs the the decision-making process. It can reduce uncertainty, it can mitigate risk, and save us some cost. Dominic is going to elaborate on that a little bit later. It also can help us to create refined outcomes that guide the clients towards sustainable and successful long-term solutions, aligning with their long-term vision and goals. So for us, this is how it looks like with prototyping and testing. So we have our product development process, and we have different phases. And with each phase, the projector turns off. I'm going to quickly check that off, and then we can continue, or somebody else can. Thank you. There it is. Great. All right. So within each phase, we can have different prototypes. Actually, we have to have them, because we see this as an iterative process, and the research goal is informing what we want to prototype and test, and therefore the prototype adapts, and towards the right face, towards the right, it also gets a narrower corridor in which we can prototype and also get testing results. And there is no solution that fits all of these phases. So we build prototypes to test concepts. So we have our research or prototyping goal, and then we can do testing with that. And then we test to gain insights and build new iterations. So we get the testing results, and we can create better prototyping tools until we meet the expectations and requirements and are aligned with our goals. Okay. So in the automotive industry, there are special requirements that we have to take into consideration when we do prototyping. For instance, there is safety. So users are challenged on many different senses. They can be audible, they can be visual, they can be touch interfaces, for instance. So we have to consider the driver attention and distraction. On the other hand, we have ergonomics. The user is actually constantly bombarded with different and new input, and therefore we have a lot of cognitive and physical load, and we have to manage that. And for instance, we can manage that through focus modes or through a very comfortable hardware setup. Then we have multimodal interactions and multisensory activity. And you may do that on a daily basis as well. You use touchscreens, you may use voice commands, and other things like gesture controls. So how can we stay easy, or how can it be easy to understand and easy to use? Cars are highly regulated, so that means that we have to have regulatory compliance and security. And then a last and very important point for us is the future-proofing aspect. Since technology is evolving very rapidly, and so are the customer demands, right? A car from 10 years ago is very different from one that comes out today. And in the past, we have seen examples for this: the metaverse, augmented reality, virtual reality. AI is coming up. And therefore, our UX designs need to be adaptable and scalable to accommodate these emerging trends and technologies. So, yeah.
In the next section, we're going to share our opinion why testing is needed to overcome the challenges in the dynamic industry. So we believe that frequent prototyping and testing is crucial for making the right decisions early on and ensuring the success of concepts. So let me give you an example, and we wanted to visualize that with a graph. So as we see here, the costs and errors, or also the failures, are rising significantly throughout the product development process that you can see here. So it means that it's getting more expensive to fix problems the later we are in the finish line. So the closer we get to the finished product, it's way more expensive. So it's way more expensive to fix a problem than in a prototype itself. So as we consider the costs, it's also important to evaluate the project risks. So testing prototypes is important in identifying potential risks before they get too costly and also difficult to fix in the end. So this can help to refine the project plan in general, to also make the necessary adjustments early on, and to mitigate risks before they are getting major. So in addition to that, it's also important to do this in iterative process. So to limit the risks to a minimum, we also have to always keep in mind that we should have these iterations, as you can see here, so to iterate in circles and to always test. So in each phase, we have to test multiple times to also remain and sustain. And also to be on time, on budget, and of course also to deliver the required quality standards. So we use different user research methods to get a better understanding of the market and the competitors, of industry regulations, of consumer and technology trends, also of user behavior and situative context, and also of the brand, the core businesses, and the user group, to create innovative concepts and to find opportunities and new business ideas. So let's take a look at how we are doing this in practice.
All right. So we divide the product development process in two parts. On the left, you can see the value proposition. So we create the value proposition. Which idea do we actually want to pursue? And on the right, the much longer part is the user experience testing. So how do we implement the idea moving on? You can see the first part as doing the right thing, and the right part as doing the thing right. So this overview presents our approach to ideating testing, and it has been used throughout different projects in different industries. And what you see here is the first segment, which is about the research and strategy part. It's important that, again, as I said earlier, the research goal defines the prototype, and therefore in each phase we have different methods that vary. So for instance, in this first part, the question would be, what do we want to achieve actually? And we can use different methods such as contextual research or co-creation workshops to try to get there. In the second phase, we have the feature testing, defining the features and testing their purpose area. And here we have pretty early low-fidelity prototypes, first rapid prototypes, I would say, and according to those prototypes, also the right methods. So here we want to get qualitative feedback. So from a few people, a few experts maybe, a few users. Therefore, we can use methods like card sorting, ideation sessions, and of course, rapid prototyping. Okay, so now in the third phase, the idea gets more tangible. And here we are in the prototyping and testing phase, as we call it. So the prototype can be actual parts of the product or some close to actual parts of the product. And here the complexity of the prototypes change, so it gets more complex towards this area. But therefore, we can also gain a higher yield, a better outcome that is more detailed. Okay, so the last phase is just before delivery. And here we can now do actual real data tests because we have a more or less refined product already. So methods that we could use here is A/B testing or shadowing, for instance. So this is the first time where we can actually do testing on a real quantitative scale. We can do that depending on the project, maybe even a bit earlier, but this is where we can actually do mass data, usually. All right, from the left to the right, as an overview here, the testing advances, and the more we turn towards the right, the details of the prototype gets more detailed, but so do the results as well. Okay, so let's go more into the tangible part, the prototyping of the automotive solutions. So we categorize prototypes in 4 different areas, and the first one is the service prototype. So here we really want to understand the user needs, and we want to make the vision tangible. So what we could do, for instance, here is a storytelling exercise to get maybe a video or a storyboard outcome. The second category is the experience prototype, and here we want to test experiences, we want to test behaviors, usability, and maybe even already detect technical limitations. One example for experience prototypes is a seat bug, which you can maybe also see over there, a rapid one. And so this is very good to actually check scenarios and do more or less real testing. And this brings me to the third category, which is the physical prototype. And here we can actually use the prototype, the hardware prototype, to explore functions, ergonomics, user reactions. And depending on the fidelity of the prototype, we can do, for instance, a check of color material finish as well, which would be a very high-end prototype, not very rapid prototype in this case. And again, we can combine physical prototypes with another category, which would be the virtual prototypes. These open up a huge range of applications because they can show a virtual scenario in VR, virtual reality, but therefore they are cheap and fast to build. Okay, so all prototype categories are important for our team. And again, the prototyping goal informs the category. So we don't have this one-fits-it-all solution in here. We have to choose based on the phase we're in.
So here you can see how we use different levels of fidelity also throughout the entire product development process in prototypes. So we select the appropriate fidelity of a prototype based on the use cases that we would like to build, or also based on the testing purpose. So let me give you a few examples. So what we could do, so we also heard about the seed bug, and I will also explain some details about it later on. So let's give you an example about the seed bug and how we also worked with a seed bug in the past. So you see that we are going from a lower fidelity to a higher fidelity throughout these different phases. And for instance, the seed bug, we can also use different methods. So once we reach that part like the seed bug, we can also go back, so kind of jump back in the phases. So we can also still use sketching and paper prototyping to get rapid ideations and to also make the ideas tangible again and again. And then afterwards we can recreate everything that we learned. So we can also still have the circles. So as Thomas explained before, we now learned a lot based on the sketching and paper prototyping. So therefore we can also mirror it back, create new interactive prototypes, make it even more feasible for the people, make it interactive with digital tools. I will also come to that in a second. And then also mirror it back again to the seed bug and integrate new features. So that helps us a lot to also save costs, of course, because we don't have to spend too much time in developing if we jump back and forth, because we figure out if new implementation is needed or not. So we call this micro-testing or feature testing. And yeah, for even higher complexity, we can also develop the seed bug further, so to also integrate physical or also digital again, which means we can also combine the physical part, the seed bug, with new features, with augmented reality, for instance, with virtual reality, and in combination with physical prototypes like 3D printed part, it gets even more tangible for the users. So you can really feel and interact with the car, but also still have virtual reality, for instance, to also see it visually. So here you can also see one of these seed bugs in a theory. So these prototypes allow fast adaptations and also bring really valuable insights in the user testing. So as we explained, we can really have the benefits of everything, the physical and the digital world. And we can also, due to its modularity, we can always combine and add new things on top. So for instance, you can add new sensors for face recognition, for eye tracking, once they are validated with sketching, for instance, or with a Wizard of Oz, which means that you're just faking things, and then you can continue with implementation to make it more feasible. Or you can also switch the displays, so you can really change displays, you can work with different dimensions, you can work with different types of displays. Or you can even integrate a voice assistant. So here we listed some of the tools that we are often using throughout these phases. So also going again from low fidelity to the implementation phase or to a higher fidelity. So let me give you a quick example of each phase. So for instance, the pen and paper prototyping, I think I also talked about it before. So we really use it for rapid ideations, for bringing up a lot of ideas and testing them rapidly with users. Then we jump to the mid-fidelity prototyping tools, so that gets a bit more interactive. So we use tools like Envision, so we're getting a bit more digital now, using Figma, for instance, to also build these first interactions, for instance, also voice interactions. And then the higher we get in fidelity, so for instance, we now would like to talk about Prototype, for instance, also in combination with other tools. It allows a lot of complexity and a lot of fidelity. So we recently built a high fidelity prototype that was used for internal presentations. And in combination with an Arduino, for instance, or also with JavaScript, it's really, really interactive, and you can also have multi-model interactions here. And you can also build voice interfaces, for instance, with it. And once we take a look at the implementation phases, you also see a lot of tools that are also out there on the market. For instance, also Unity and Unreal, where you can also create 3D HMI, and that's content that you can already use in the HMI in the development process later on. So these are just a few examples, and there are a lot of more tools, but we would like to keep it short here. So by creating different automotive prototypes with increased fidelity and complexity, we can ensure a higher validity of the data to our testing and evaluation process. So that's the thing that we explained before. So the higher we are in the fidelity, the higher the fidelity of the data will also be in the testings later on. So again, let me give you a few examples of projects that we've been working on. So also, again, split it in these 3 categories, low to high fidelity. For the low fidelity, also, again, sketching and paper prototyping and how we used it. Due to its modularity, flexibility, and the iterations and adjustments that are done easily, as I said, it's a nice tool to also figure out opportunity areas, figure out things, and figure out opportunities where you can continue working on. For instance, with a cardboard mockup, you already get a good understanding. Then let me explain some mid-fidelity seed bugs in that case that we've been building. So these allow a lot of detailed HMI refinements. So once we are a bit more in the digital world now, you also get a lot of visualization. You can also work on dimensions. For instance, you can resize UI elements, you can test them, you can iterate and ideate on that. It is very flexible and modular, so also, as we explained before, you can add new sensors, new actuators, and also in terms of usage video content, it also allows realistic scenarios, so we can also build very realistic and tangible experiences with that. In that case, we used it for concept visualization and also for the refinement of the scenarios and future scenario visualization in general. And now let's jump to the last part, the high fidelity part. So here we created a high fidelity mockup that's also using real sensor data, also from the car, and also, for instance, weather data that can be integrated in these types of prototypes. They allow a lot of accuracy, and they are almost close to the reality. So they are very tangible. They are very real, so to say, so you can really test in real conditions because you get the data from the car. And with these in-car testings, you can evaluate, for instance, interactions, steering wheel concepts, and really refine your interface in the last phases of the projects.
All right. So, yeah, what are the key takeaways and insights that we want to leave you with? So we clustered it in 2 areas, and the first one is why prototyping and testing matters in the automotive field. So the automotive industry is a unique testing ground. As I explained earlier, we have a very high complexity in a car scenario. There are special requirements such as safety, ergonomics, regulations, and we find ourselves in a very rapidly changing environment. The industry is rapidly changing, and so are the customer demands. The second point is prototyping early significantly reduces development costs. So as Dominic explained, we'd like to call it the fail early approach, where we identify issues early on and opportunities early on. So yeah, this helps to reduce the cost significantly. And the third part is it helps to meet desired quality and exceed customer expectations. So through prototyping and testing, we meet or exceed customer demands and expectations, and that helps the client to stay competitive, to drive innovation as well.
So we'd also like to give you a quick summary on how to use prototyping and testing also in your projects. So first of all, you should really focus on a core testing issue, and also you should also vary per test. So that means that a prototype should address a central testing issue and vary based on what is being tested. Another very important important point is to select the appropriate tool based on what you would like to achieve and also based on the testing purpose. So also again, that example of the high fidelity seat bug that we've been building, so you can really use it in the later phases, for instance, so you always have to evaluate which tool to use when. So kind of every tool has its own time point, so to say. And last but not least, the more accurate and detailed the prototype is, the more accurate will also be the resulting data. So prototypes that are really in a high fidelity also give a lot of valid data that you can also use for building new iterations and ideate even further. And now we would like to thank you and also hear your thoughts and questions. So as Manuel explained at the beginning, we prepared a Menti and also would like to invite the crowd that is here today to share your thoughts and also address your questions if you have any.
Thank you, Thomas and Dominic. We won't keep you too long in this room, but we wanted to take maybe 3 or 4 questions before we continue with having drinks and food. And I will also make sure the microphone gets to you if you have any questions. So there is one. Yep.
Yeah, question, what do you think about trend in automotive industry to remove hard buttons and move all controls to screen? And do you have any test to examine influence on safety by this remove?
All right. Okay, thank you. Yeah, no, great question. Do you want to take it, or I can take my. Okay, so since I'm coming from the industrial design background, so for me the removal of the buttons is, yeah, of course you have to test and you have to see how you can get a car or an environment that is suitable for the ergonomics, correct? So in our view, it would be that you can have screens only, but the idea would be you need to test it. So for instance, crucial controls such as, or controls that you want to reach very often, you should test if the ergonomics would fit for that. So do you have the correct arm reach, for instance, to reach those controls? Another thing is that you get a tangible experience with buttons, with touch buttons that actually react to you. Therefore, in many cases, a reduction of the physical input models can reduce complexity in the visual approach, but not really in your motorized skills, right? So I think it's a tricky discussion. I cannot really answer what is the better one, but I would always urge that testing here would be very crucial. For instance, using a seat bug to understand how your user interface works. That's a very vague answer, but I hope it sort of gets there.
Yes, and maybe on top of that, also if we evaluate new technologies, for instance, that are coming up, I think that's a good way to also use that testing. So I'm also not a big fan of removing every button in the car, but keeping it, as Thomas said, keeping the necessary buttons, for instance. But if there are new ways, for instance, gesture control and so on, there are way more things that you can also experience with it. So therefore you can also test it and make it really understandable for people and also for you, and use the testing.
Thank you. I don't know if we have to clap. Maybe there's more questions, but thank you. Yeah.
So I have 2 questions. The first one is, how are you able to recruit participants for these tests? And the second one is, once these concepts are handed back to the clients, are you able to track the fate of these concepts in a way?
Mm-hmm. Yep, so if I understood your first question right, it's about how we would set up a screener, how we would get to test that. The first one is, I would say, based on many different parts, of course. It's based on your user persona that you're pursuing, or the customer's target audience. It's based on a cultural area. We have in the past worked with many different clients all over the world, and we understand that any different cultural area has their own different tweak to certain things, and you have to understand that. So how we would approach that is either we can have expert interviews, for instance, that are more on a qualitative base. So we ask a few people early on. We want to have that pretty much at the start of any project. There we can get a download of a lot of input already that doesn't need to be necessarily answered in a sort of a mass testing. And there is a lot of data you cannot really test in this quantitative scale. Moving forward, we would then also, sometimes we have experts within our teams, within our group, right? But later on, if we are going to do mass testing, we also have a screener for third-party companies that would then bring us the people, so we can reach the whole world, basically, and then do the testing. Depending on if we have a hardware prototype, of course, we would have to do that on-site. We would do interviews and things like these. But if we can do it online only, then that's also valid, yeah. Now I forgot the second question.
It was if you're able to track the fate of these concepts once they're handed over to the clients, about whether they were actually implemented or what's the state there.
Yeah, that's a difficult one. So that talks about what happens with the data, right? So of course, we usually work in a project. So usually we try to work end to end, right? So we try to work even more or less just before delivery. But that really is a task of how we analyze also. So we need to, once we get the raw data, we don't sort of hand it over usually. Of course we can do that, but usually we try to narrow it down, cluster the feedback into actionable tasks in a way, or executable tasks, and then we go from there, and that's usually what we present. So in a way, if we would do a revision or an iteration of that process, we would have to have either data management software or something. For basic research, it can also be a Miro board, for instance, and then we hand over data and discuss it very quickly and iteratively. Yeah. Did I miss something?
No, I don't think so.
Thank you. Yeah.
Thank you for
great
the
questions.
answer.
Yeah, thank you. And you make it easy. The question was, again, very close to me.
So my question is, how is it with the regulations in the automotive sector? Because sometimes you improve the user experience, but sometimes you maybe change some parts. It could be also, I would say, maybe dangerous or not. So I think some features you change, for example, the warning light should be always easy to reachable. But how is it with the regulations? Are there some written down, or should there be some written down in the future? Or what do you think about this?
Yes. So there are a lot of regulations, of course. Also, if we talk about telltales, for instance, you always have to keep them in mind. You always have to have an area for them. You always have to keep this in mind while designing interfaces, HMIs. And I think that's one of the toughest one if it comes to visual design. And if it comes to the general concepts, I think it's always kind of a back and forth, so you always have to integrate them, evaluate them, test them again. And I think that part is a bit harder because the other regulations are a bit more written down. Yeah. And so there's no one solution fits all, because, for instance, some companies also try to be a bit more rapid or try to be a bit more innovative and also change things. Sometimes it works, sometimes not, but due to these regulations, you still have to keep this in mind.
Yeah, and in addition, I would add that as a designer, right, you don't know it all. So you have to get an expert, and usually that's what we also have. So if we have regulations that are tough, so for instance, in the past I've worked on a product that was also dealing with disability, then you have to have an expert. You don't understand the regulations. Actually, after a while, you read all of them, and then you understand them, but it takes you a while. So it's always best to consult an expert first, to go through your steps or your idea with them, and then align. Yeah. So, yeah.
Thank you. I would say let's take one more questions. There was also a lot of questions online, but maybe we can take one of these later when you guys actually want to approach Thomas and Dominic and ask them about the toughest thing about building that seat bug. So that was a question that came through Menti. But there's one more question, I would say, let's take that one.
Thank you. Hi, so my question is about the tooling you use. You had a great point of saying that the tooling, especially for the software prototyping, is depending on the phase and also on the purpose you're going for. However, I would like, are there any go-to tools for you guys that you say, this is where we're really at home, and this is what we use frequently, of course, for different purposes?
Yes, I can add on that. So, yeah, first of all, I think first iterations are very easily built in Figma, or not easily, but you can be very iterative due to a lot of tools, like for instance Figma, and I would say Figma is one of our tools that we're using frequently, especially in the earlier phases, especially for HMI, of course, and also to bring the first ideas to the clients or to the customers to test them, and also to make them interactive, because it's the perfect combination of making the visual design, but also, of course, making it interactive. And added on top, I would say the second tool is Protopy. It's definitely Protopy, because it's like the ideas are getting way more experienceable, and you get a lot of interaction. You also get multi-screen interactions. You also can integrate real data, and you also, as we mentioned before, you can also integrate the data from the car in these tools and also use weather data. So it's very, very close to production ready. So if you hand it over to people, let them test it, for them it really feels like an app, because it gets your location, it can figure out your tilt of the device and stuff like that. So that's the reason why we would say it's, in that case, definitely Protopy.
Yeah, and what I can add is that we have in the past had very simple seat bugs, for instance, where it was just a screen and a seat. But later on, we also developed more and more hardware processes. So we use CAD tools, for instance, Rhino, SolidWorks, whatever, to get to a certain stage, and then we can actually fuse both. And I think that's at least where I love to be, to have both worlds coming together. Yes. Thank you. Awesome question.
Yes, thanks.
Yeah, thank you for the questions. Thank you for coming tonight and for donating parts of your evening. If you've joined online, thank you for maybe donating parts of your afternoon or morning. Thank you for the interest and the great questions. If you have more questions, please ask us during the remaining evening. And for now, I would say we close the forum here, but we are around. So please chat us up and talk to us about prototyping and maybe why that thing back there in the corner was so hard to build. So thank you very much.
Thank you.
Thanks.